Bengawan UV RoboBoat Team is a subdivision of Bengawan UV Sebelas Maret University Team, which has been established since 2016. This team focused on advanced research in science and technology, especially on unmanned surface vehicle field. This is the first year for Bengawan UV team to compete and focuses on research, development, and building autonomous vehicle for RoboBoat competition.
To develop our skill and experiences on hull design and simulation that we previously got from national level competition, Bengawan UV RoboBoat team that compete in 2021 RoboBoat proposed an automatic ship called Mandakini Neo. To achieve maximum output in performance, our ship prototype was strongly influenced by a predetermined design. From various types of hulls like displacement hull, planing hull, and multi-hull, we choose to design our ship with an asymmetric catamaran hull. By applying many existing theories, we conducted a test as a way to develop our design, and we also done some simulation with the hull design so the ship able to complete the mission on 2021 RoboBoat competition. In order to press down the budget and also to be more efficient on time and other resources, we choose to continue our previous time research with some adjustment and development plans, so we are confident that we can complete the mission on 2021 RoboBoat. In completing the mission's course, we done some tests and proper measurements to support the performance of our ship prototype. Some of the tests that we did are stability tests, resistance tests, seakeeping, and also maneuver tests, which then continue with further trials and errors. We also apply other innovation and evaluation for our team supervisor regarding our ship prototype, so we can continue thriving and step up onto this international stage, which is 2021 RoboBoat. More detail regarding the discussion of prototype from our team will be discussed in the next subchapter in achieving best result from our team prototype.
A hull is one of the main parts that builds the entirety of a ship. Each and every kind of hull types has its own different characteristics depending on the purpose and usage of the ship. The 2021 RoboBoat competition has 6 missions that needs to be completed. But to continue to the rest of the mission, we first need to complete the first mission, which is mandatory navigation channel. Analysis that we done show that every mission needs a hull type that has a low resistance rate and high stability. That being said, we choose to use asymmetric catamaran hull that fits the needs for the mission. The first strategy that we used was to make sure the performance of the ship hull by doing an approach with software simulation by using Maxuf software that developed by Bentley. The simulation that we did were analysis on resistance rate, stability rate, seakeeping, and also maneuverability. Resistance is a fluid force that works or impacting the ship that in a way resists the movement of the ship. The next analysis is on stability. Stability is the ability of the ship to return to its previous position after getting an impact that affects the ship slope. The last analysis, which are on seakeeping and maneuverability, is done to find out the ship maneuvers. Maneuverability on a ship is very important because it will determine the safety and efficiency of the ship on its course.
The second strategy is to determine the ship main dimension ratio that correspond on the ship stability. That being said, our team developed the ship stability by calculating the ratio of the ship dimension. The dimension ratio consists of the ratio of length overall and beam and depth, and also length overall and depth. The smaller the ratio between length overall and beam, then the greater the movement resistance value and will have a bad impact on the ship speed. Meanwhile, if the ratio between length overall and depth has a large feature, that it will have a bad impact on the longitudinal strength. For the neck ratio, the greater the beam and depth ratio, then the ship will has a great stability. To determine the stability of the ship, we compare 6 designs that has the same hull and length overall shape, which is 90 cm, while the beam and depth each has different value but still on the limitation of the dimension that already been determined. From the stability analysis that we did, the greatest stability value that we got as reckoning level value of 14.7 and angle of finishing stability of 30 degree. The design that has the greatest stability outcome has length overall value of 90 cm, beam 50 cm, and depth 30 cm. So it will support the ship on completing 2021 RoboBoat mission.
The third strategy is on the determination of the material that being used for the ship prototype. For the previous ship design, we choose fiberglass as the material. On RoboBoat competition, we choose to do more research and development in order to get better material than fiberglass, and we come up with carbon fiber as the material for our prototype. The advantages of using the carbon fiber material are like tensile and compressive strength, and it has lower density rate than fiberglass. For the mechanical properties, carbon fiber has a tensile modulus value of 276 GPa and a tensile strength value of 5413 MPa. Based on the value of tensile modulus and tensile strength, we can conclude that carbon fiber is better than fiberglass.
Before we test the ship on the actual trajectory, first, a simulation analysis was carried out to determine the resistance and stability values through the master software. The theory we use in finding resistance values is the Sebelas method. The Sebelas method takes into account resistance at the trim angle with speed. The results obtained from the simulation are that the resistance value of 11.54 Newton at speed of 2 meters per second, 12.53 Newton at the speed of 3 meters per second, 15.16 Newton at the speed of 4 meters per second, and 19.85 Newton at the speed of 5 meters per second. Then, we did the test directly on the trajectory that had been made to validate the result obtained from the simulation testing. The ship at a speed of 3 meters per second with several variations of the distance 6 meters, 8 meters. From the test result, the average time is 2.16 seconds, 2.77 and 3.46 seconds. From the test we have done, the ship is capable of run at stable speed and efficiency battery consumption, so that it can be support the completion of the mission. To determine the stability criteria using the roll period test method, which one of the tests to determine stability characteristics of the ship. The rolling tests must be careful because the stability check with the rolling period only measure the metacenter point. Based on the result of the tests that have been carried out, the metacenter point value obtained according to the equation of rolling period is that the degree angle of vanishing has a metacenter point value of 0.59 meter, while the 30 degrees angle of vanishing has a metacenter point value of 0.36 meter. The stability criteria for a small vessel less than 24 meter, according to a German Elliott and Registro Italiano Navale, states that the metacenter point must be more than 0.35 meter, while the Mandicanian ship is more than a value of 0.35 meter, so this meets the criteria for a good ship stability.
The development of the material that Bengawan UV tip did, resulting in a turnover from fiberglass to carbon fiber by considering the stiffness and strength aspect of the material. The previous method that we did in using the fiberglass is hand-up fabrication method. Then with carbon fiber, the method that we choose is vacuum bagging technology. Vacuum bagging is a way from making composite specimens by pressing with vacuum bag to suppress a lamination from gel coat, fiber, and other layer on the mold until all the layer merge into a structured composite. From tensile testing, we know that the tensile strength of a composite with vacuum bagging fabrication method is higher than with hand layup method with the increase of 29.41%. Also from stiffness chart, vacuum bagging shows higher stiffness rate than hand layup with the increase of 19.30%. The result is possible because the tensile strength from vacuum bag method is higher than the hand layup. From the fabrication side, the material that being made with vacuum bagging method has better metric bond, resulting a stronger material.